Hi, my name is Monique Verstegen and I work at the Department of Surgery at the Erasmus MC in Rotterdam. I'm sorry I cannot join this great seminar today. I'm enjoying a holiday in Iceland. Anyhow, this is our institute in Rotterdam, and you can see in the left buildings we have our offices and our lab. And this is our team. Really great team of young researchers, very keen on working on cholangiocarcinoma. And we actually approach this as a tissue engineering way. It's quite basic research that we do using liver tumor organoids that we grow from small tumor biopsies. You can see them here. They grow very much different than the regular organoids. And you can expand them and do lots of experiments with these organoids. We also, of course, know that a tumor is not just consisting of epithelial tumor cells, but as you probably know, there is a very thick stroma surrounding the tumor in cholangiocarcinoma, and we are very much interested in the interactions of the tumor cells with other cells in this environment, but also in the extracellular matrix. And for that, we use a technology called decellularization, which can remove all the cells, end up with the extracellular matrix of the tumor to enable analysis of just this extracellular matrix. So what we do is get small biopsies from the tumor and from tumor-free liver from the same patient and decellularize this to get rid of all the cells and end up with the extracellular matrix, after which we can do many characterizations such as biomechanicals, proteomic, we can do some stainings and look at how biocompatible they are. So when we have both the organoids but also the extracellular matrix, we can also look at how the interaction between tumor cells and their extracellular matrix is. And for that we combine the tumor with the extracellular matrix, and we can already see here that the organoids grow nicely in this extracellular matrix, but more importantly, that they have a different gene expression depending on the environment that they grow in. So when tumor organoids are growing in their native, tumor extracellular matrix, they have a much different gene expression profile than when they grow in a tumor-free liver matrix. That's important things to know, and we will, of course, now elaborating on this. What we did find is that when we use this model, so growing organoids in their own environment, their gene expression looks much more like the regular than the patient tumor tissue. And when we use other models, also exposure to gemcitabine and cisplatin shows that the cell viability in organoids growing in their tumor environment is much higher, so they're less sensitive to the drugs than compared to when they're growing in tumor-free liver matrix, which is actually more reflecting what's happening in the patient. Also, patients are more chemo insensitive to chemotherapy. Of course, we need to figure out more and extend this model, and that's something you could work on in our group. And at the same time, we're also looking into the composition and spatial distribution of, for instance, cancer-associated fibroblast subsets in the tumor. We use a very nice imaging cytometry technology for that in collaboration with UMC in Utrecht. And to understand what's the interaction of the ECM and the cells, how ECM is deposited and remodeled in the tumor. Of course, this is all work in progress, and that's actually what I wanted to share with you today. Thank you for your attention. And if you have any questions, please just contact me through email.